Hello everyone, thank you for coming. I wanted to do some starting up tests, make sure everyone can hear me properly, make sure my screen is visible. Up. Also check this on mine, but for those who are here, if you can tell me, if you can hear me properly, that would be really appreciated. Looks and sounds good. Thank you. Floon. My apologies if I pronounced that incorrectly. I'm still only seeing a few people online, so how about we wait a couple more minutes and then we'll get started. In the past, I've hosted these sessions and they've lasted about 2.5 hours each, but hopefully we won't be here for that long today. Hopefully we can do things a bit faster, and if needed, host more sessions in the future. And by the future, I mean starting next week. And feel free to say hello in chat. I know this having a chat like this makes this a lot easier for some of us because you're hiding behind a screen. You may not be using your real name. Perfectly fine. You can remain anonymous if you wish, but feel free to say hello and to let me know that you're here, and to let others know that you're here as well, and just so it doesn't look like I'm talking to myself. Right. Let's get started at 6:04. My screen is showing 6:03 right now. Don't think that's part of the screen is visible on the stream because what I have is I think the right part is showing the chat window with a black background. So that part of the screen has been cut off. And unfortunately, we need the black background so that the text actually pops out and it doesn't get lost with the rest of the screen. Anyways, so let's get started. Hello everyone, welcome to a new channel or series, hopefully, that I'm trying to call it Foo-Bar, which we'll see why those, if you haven't seen that term before, we will see them shortly. What this is going to be about is about Java concepts review and object-oriented programming review session. It is open to all public, but this is being focused on at the University of Calgary, the introductory computer science courses, CPSC 219 and 233. And to get started, so a bit of the abstract for today is going to be, I'm going to talk a little bit about myself, only a minute or so, and tell you why I'm doing this. I'll give you a few overview of this channel and this particular session, and then we'll actually jump into the content for today's session. And these are what we have so far. And then in the future, if you would like to see some other topics to be discovered or to be covered in these sessions, please do send me an email or contact me through Twitter. Send a message on the chat here. Discuss on D2L, and then we can create more sessions if needed with other topics. So a very brief description about myself. I'm a PhD candidate at the University of Calgary in the Department of Computer Science. I enjoy teaching, especially the Computer Science 233 course. Teaching as a TA. I haven't been an instructor for that course yet. My education background, so as you can see, I had my bachelor's from 2009-2013 at the University of Calgary. Then I jumped into my master's from 2013-2015, again at the University of Calgary. And then as soon as I finished my master's, I jumped into the PhD, hopefully finishing by early next year. As a grad student, we get to be a teaching assistant at the University of Calgary. This is essentially where our funding comes from. And each semester we get to TA a course. So these are the courses that I have TA'd. As you can see, I've TA'd Computer Science 233 quite often. And I've worked with certain instructors more often than others. And I've also taken other courses such as CPSC 525. I was the instructor for 101 and 102, which were the introductory Linux or Unix courses. Unfortunately, we don't offer those anymore. There's also CPSC 413 and 329, which is the Introduction to Security course. So a bit about this channel and this session. So first of all, I'm doing this on my own. This is not requested from me from the course instructors. This is my own thing. I enjoy doing these types of sessions. So this is just my own thing. It's not part of my TA duties. We'll be focusing on Java, and as I mentioned earlier, we'll be focusing on Java and object-oriented programming concepts review. Once again, this is focusing on CPSC 219 and 233 courses offered at the University of Calgary. And we'll be focusing on the first month or so, first month and a half of what we saw in those courses. And instead of just being this is a place where you get started on these concepts, this is more of a review. So I do expect some kind of level background. So feel free to ask questions and answer questions in chat. I will be monitoring chat. I have it open on my laptop. I'll try to answer many questions as I go along. We do have an abstract, as I mentioned earlier, but we do want to remain on topic. A few rules about the chat itself is, first of all, please, common courtesy. We are professionals here. Well, I don't need to say anything more about that. So common courtesy. Do keep things clean, please. This is supposed to be related to the university courses, so let's not get too out of control. And please, no spamming. I will block you if you are spamming. So use the chat for asking questions, clarification of concepts. If you have answers to other people's questions, feel free to answer them as well. And this way, we can keep the session going as fast as possible. All right. And I realize there's a bit of a delay with me talking and what you are seeing, so I'll try to wait a few seconds every time I move on to the next part, just in case anyone has questions, and I don't want to move too fast. Okay, so getting the topics to cover today, so we'll start off with arrays and array lists. So these are fairly straightforward, something from the very beginning of the course. I'll try to move fast through these. But just a basic description on and how to use these two things. I'll also talk about loops, so for loops, while loops, and for each loops. Again, fairly straightforward, but so we'll go through fast. And then we'll get to the more complex content, such as the classes, methods and constructors, method arguments, where we have passing by value versus passing by reference. We'll also talk about privacy leaks, which there was a request for this particular topic. On how to take care of privacy leaks, how to identify privacy leaks, and when is it okay to have privacy leaks. So we'll have a discussion about that. And then last but not least, we'll end up with null references, essentially how to work with them and how to take care of situations where null references occur. And then if we have more time, we'll try to address more questions. But let's see how this goes. So what you're seeing here is my screen here. I will be working with the Eclipse IDE. So that everything can move fairly fast. I did increase the font sizes so that everyone can see things properly. Just to confirm, do let me know if you can see this code. And hopefully it's big and clear. I'll also show the output down here. So I increased the font size. Hopefully this is visible. If anyone can confirm in chat, please do so. Okay, looks good. Thank you. Okay, so let's get started with just basic arrays and array lists here. So we'll do arrays first. Not what I wanted. Okay. So arrays are essentially a collection of certain objects or primitives. So for example, the way we work with arrays is we specify the type of the array. So let's say that we're going to create an array of type ints. We use the square brackets here. we give the variable a name. So I'm just going to call this int array. And then we use the keyword new, again type. And then now within the square brackets, we specify how many entries are there going to be. So let's say there's 10. And then we can access each entry by using the index. So we would have the array name, so in this case int array. And then let's say we want to add access index 4. And now we can assign it a value. Note that the value has to be the same as the type of the array itself. So, let's say 32. And when we do things like this, so let's say we can trying to print. I'm not sure why the computer is acting a bit slow right now. Index 4. So if we did everything right, it should print 32 down here, which it does, luckily. If we were to access something that we haven't assigned yet, by the nature of Java, I think this would, instead of a 0, let's say index 2, we haven't assigned anything to index 2 yet, but by the nature of Java, this turns into 0 because everything is initialized to zeros. That's why any other index other than 4 is set to 0. And then one thing to note about arrays is that we have to know what the size is going to be beforehand. If we don't know the size, then either you're creating an array that's too big, which you're wasting a lot of space there, or you're creating an array that's too small, which is going to run into problems in the future because you don't have enough space to actually store that content. But the fast thing about arrays is that you can access by index quite quickly. And this is especially useful where you have large arrays, a lot of content, and you may not be only working with primitive type of int, you could be working with something more complex, classes type. That's where the speed comes in handy as well, and efficiency. Similar to arrays, we have ArrayLists. So this is where things get a bit, not necessarily slower, but a bit more complex, I guess, where we have a bit more capabilities than arrays, but it comes at a cost. So when you do ArrayLists, we specify the type, again, integer. Note that arrays can work with primitive types, as we see here, but ArrayLists, we want to see non-primitive types, actual classes. And then are we going to call this, just call this ARR, again, new ArrayList. So one thing I skipped over was what am I doing here within these triangle braces, and that is we're specifying the type of the array list. Now, array list is a class. It's a parameterized type, or it's a generic type rather, and it can work with different types. An array list can hold various types, so it's not just integers. It can hold any type of class. And in these triangle braces, we specify what class we are working with. In this case, we are working with integers. And again, when you're adding to arrays, or rather array lists, we use the add method. Note that we can't just use the square brackets in this case. So we can say add 15. And we can say arr.add 12. So we can add various values here. Now what that's going to do, oops, not at all. What that's going to do is allow us to retrieve values and then again do anything we want with them. So for example, if you wanted to print them again, I'm going to change the previous line here. We use the get method, and then we specify the index of what we want to get. Now, array lists we can add, or rather arrays we can add anywhere within the index. Array lists we want to work with one incrementing index. So the first thing would be added at index 0, added at index 1, and so forth. So for example, if we get arr.getZero, and we try to run this, it should return 15 because that's at index 0. If we say return at index 12, not index 12, but rather index 1, to return us 12. Now what happens if we say array dot get index 2? What would happen there? Could crash, or it could just give us 0 again. To be honest, I don't know off the top of my head, so try it. In this case, it crashes because so far we've only added two items to the array list. And now we're trying to access an item at index 3, but that doesn't exist. So what this means is we want to be careful as to what index we're accessing. This was a very, very quick overview of arrays and array lists. Now just to jump into for loops, rather what I want to do is that we're done here. Do we have any questions about arrays and array lists before we move on? I know this was a very brief overview, something really quick, but essentially I just wanted to cover what are they and the very basic syntax for those. Okay, I'm not seeing anything in chat yet, so let's move on to loops. So starting off with for loops work by starting with the keyword for. We open parentheses, we specify counter variable. A lot of times we just call it I for index, but you're free to choose whatever name you like. You want to have a meaningful name because when you actually have a body of the for loop, instead of just seeing a random variable name, having a meaningful name will help you understand what's going on. Or rather, if someone else is reading your code, it will help them understand what is going on. And then now, after the initialization, we specify an end condition. So how long do we want the loop to go for? So we say as long as I is less than int array.length. Meaning it's going to go through each index, or we want to go through each index of the int array. And then the increment, how do we want to go? So this is starting from the first element and then going to the very end. Just to be safe, I want to say I equal to 0. So I has been initialized. Now what I can do is say int array at index I equals I times 10, for example. Now what this is going to do is it's going to iterate through each index in the array, and it's going to set a value for each index. And then similarly, we can do another loop. So you see that the signature of the loop is the same as before. And now we can actually print the content of the loop itself, or the array itself. So we just print index value at each line. Again, if we run it, what did we forget? Oh. Forgot to comment out this line. That's what caused the out of bound index exception before. Let's run it. And so we get starting at index 0, then you can see we're doing I times 10. And then it goes 10, 20, 30, all the way up to 90. We do have a question here. It says, is int array a new random array you just created, or is... So int array is an array I just created. It's up here. It's not something that's built into Java. This is an array I created within this main method. Thank you for that question. That's essentially for loops. Now you can do more complex things within the body of the for loop. The thing to keep in mind is this index is going to increment by 1 every single time, as we specified here. If we wanted to increment it by more than 1, we could do I equals I plus 2. So this is going to increment by 2 or 3 or 4 and so on. But a lot of times you just do I++ or I minus minus if we're counting down instead. These are for loops. Similarly, we have while loops. Going to, let's see. I'm just gonna keep moving things down. Okay. So while loops are a bit different because we don't have this kind of criteria for a while loop. What we do is we have the keyword while, parentheses, curly braces, and then we specify a Boolean condition here. So while something is true, I want to say while I is less than int array dot length. So same to what we have here. But you may notice we haven't specified I equals 0 yet, and that's why this variable I is underlined red. So we have to specify int I equals 0 first. Another thing about for loops that I forgot to mention is when we create this variable I, it's only visible within the body of the for loop. As soon as we exit the for loop, this variable disappears. That's why we can create a different variable called I here, because this particular I, as you can see, it's not being highlighted. So it's as soon as we get at the end of the loop, the variable disappears. Disappears from memory of Java, JVM. And now we can do something else here. And then we can say int array, again, I equals, let's say, I times 2 this time, instead of I times 10. Another thing that we have to do is, if you recall, we have to increment I manually. Because, again, this is not part of the while loop. We can do I++ here. We have another question saying, will there be a saved recording of this stream? There will be a saved recording as long as the stream itself people are attending. Then there will be a saved recording. If everyone leaves and I'm just talking to myself for about an hour or so, then there wouldn't be a saved recording, and there wouldn't be any future streams either. This is meant to be a live session with discussion back and forth. Okay. Right, so while loops, the same thing here. I'm just going to copy this, and I want to say essentially print the content again. And one thing that's going to happen is, at first, this loop is not going to go through. Show you. Yeah, I want to save it. So notice that the second part does not get printed here. This loop is not being executed because when the first while loop goes through, this I is already at 10 at the end of this loop. So we have to reinitialize I here, or rather reset I here. And then when we try to run it, we get the updated results right here, 0 to 18, because we multiplied it by 2. A difference between a while loop and a for loop. Normally for loops are used in cases where you know exactly how many times you're going to iterate through the loop. So in this case, where we knew that we are going to be iterating this many times based on the length of the array, we use for loops. But if it was a case where we didn't know how many times we're going to be iterating through the loop, then that's the case where we use a while loop. So for example, if you're searching through an array and you're trying to find the first odd integer in there, you don't know where that integer could be. So it could be the first index, the second, third, fourth, however many possibilities are there. So in that case, you might want to use a while loop, because you don't necessarily need to iterate through the whole array. All you need to do is find that first odd integer. So that's the difference between for loops and while loops. Now, for each loops are also really handy. They're used for when you're iterating through either an array or an array list or some kind of collection. For example, do something like for int value int array. Now what this is going to do is it's going to go through the contents of int array, the same array that we have earlier, and it's going to take the first index, it's going to save it in the variable called val, or value, and now we can do something with it. In this case, we are printing it. And then once we're done with this loop body, we're going to reiterate, iterate through it again. Now we'll look at the second index, save that as val, and then do something with it, then the third index, and so on. If we were to do this, play it. So this was our original for loop printing. This was our while loop printing, and this is our for each loop printing. But as I said, look at the first index, save it as val, print as value 0. Second index is val2, print the value 2, and so on, all the way until we get to the very end of that array. And this is for this is a for each loop with an array. We could have done an array list as well. I think we called it what, ARR. Could have done this as well. Now, if you run it the very last time, you see that the last two values being printed are 15 and 12, which is what we added to our array list. That was a very brief overview again of loops. We talked about for loops, while loops, and for each loops. Do we have any questions regarding these topics? Wait a few seconds here. All right, we have no questions here. We can say that this is done. Now we can actually get to the more complex topics that we have seen, starting off with different classes. Now notice, or recall rather, that Java is an object-oriented programming. Whenever you're working with a project in Java, classes are meant to represent objects. So if you were to have a like a real-life representation of the project that you're creating, what physical objects would exist there, and you want to create a class for each of those. So for example, if you are playing, let's say, a simple board game, Monopoly. I think that's a bit too complex to program in. Let's say Chutes and Ladders. That's a classic, fairly straightforward. Now the physical objects for those are the pawns for each player. There's a die or multiple dice, depending on how you like to play it. There is a physical board, and I think those are the only three things that we need for actually playing the game. Well, unless you include the actual people as well. But we can combine player and pawn one together, because the pawn represents the player. So there would be at least those three things as different classes. So there would be a board class, which actually represents the board. There would be a die class, which represents a die. And then if you have multiple dice, notice that they're all the same object, or rather they're the same type of object, but different instances. So, two different die, they're both dies, but there's just multiple instances of those. So you can use the die class to create multiple dice. And then same thing for a player or pawn. You may have multiple players, but each player is supposed to behave the same way. So that's why you can have a single player class, but have multiple player objects for that kind of project. So let's actually get something a bit going. We'll start off with creating a class called person. So here, what I'm trying to do is represent person. What the situation here is let's say we have a university situation where we have university entity, we have people who are enrolled in the university, we have students who actually are enrolled as students, we have faculty members or instructors or staff who work at the university. Now faculty members and instructors, they behave a bit differently than students, but they're also people. So they do have something in common, but something that are different. So this class would represent a person. And now we can create multiple instances of this class to represent multiple people. Each instance would represent a single person. And now what do we want to have? What do we need for a person to have? So let's say in this example, we say that a person has a name. And now, since they're a university entity, let's say they also have an ID number. Is there anything else that we would like a person to have in this case? Well, I guess we can also call it, they have a phone number or emergency contacts and all. So that if someone have any suggestions to if more instance variables to add, we can. But unless someone does, I'll go with these three. But what I'm trying to say here is that person has three values. They have a name, they have an ID number, and they have a phone number. And what we can do is we can have this class do certain things. So for example, we can say public. We can create a method called public void say name. And what this method would do is print out a person's name. Just add some documentation here. So this is something a person can do. They can say their name, for example. Another thing we can do is give a person a name. So we can set a value for their name. So we can say, let's say we have setters. Then say that a person is a set name. Then the argument comes in as name. This dot name equals name. And I realize I just used the operator this here. We will go over this shortly. So a person may have three values. So they have a name, they have an ID number, they have a phone number. But the only things they can do are these two things. They can take a name, meaning a person can be given a name, and a person can say their own name. That's the only two things that a person can do. Now, if we were to create a driver class, and the driver kind of works as our big universe. This is where everything takes place and everything gets started. We do have a question on a simple website that is if search bar. I'm not sure, Null. Someone else knows, please do respond. Okay. Coming back to here, we have our driver, where our main method is. So here what we do is we can create a person. Let's give him a name P1, new person. Now this is how we create an object. For this whole line, what we're doing here, this is the part where we are initializing, or rather we're creating a variable name. That's it. Person P1, let's say we just comment the rest out. We're creating a variable name P1, and this is going to hold a type person. That's it. And it's similar to when we do, let's say, int I or string s, something like that. So we're creating a variable with this name of this type. When you're working with objects, it's no different than working with primitives. Now the next part of this statement is the equals new person. This is when we're creating the new person. This is when we're creating a new person object. This would be in memory of the JVM, the Java Virtual Machine. It'll create an actual person object. Now with the equal symbol, we're just assigning this value, or rather this the reference to this object, to this variable P1. So we have a person P1, and what we can do is we can make them do the things that we said are possible in this person class. We can give this person a name, and then we can have them say their name. So we can say P1 dot set name, and then we can give it a name give it a name Joe. And then our P1 can also say their name, right? Because that was the other method that we specified. If we run this, essentially it's just going to print out this person's name. Not very exciting. So what we can do is have a person introduce himself. Prints a personal introduction. This would be similar to say name, but a bit different. It'll print out a different message. Public void introduce. What they're going to say here is hello. System.println. Hello, my name is. What am I missing here? Oh, okay. I realize that. What I can do is this way, essentially. A person can either just say their name or they can introduce themselves. So if we do p1.introduce, it'll print this whole message. Now let's say if we have a different person, we can create a new one. Person p2 equals, again, new person. But this person would have a different name. I'm gonna pick a name from the chat. Here we go. And now when this person introduces themselves, it will print their own name as compared to Joe's name. So here we have two different objects in memory. One of them is being referred to by the variable p1. The other one is being referred to by the variable p2. And they both have different values for the instance variables. So one of them has the name Joe, and the other one has the name IRFLoon. That's a very basic description of what a class is. Now we can do different things. So for example, let's say we can do ID. We can set their ID numbers and then change them around. So this would be public void set ID. Now we can actually, what we can do is public void, we can update their ID, or rather increment. And this will just essentially increment their ID by 1. So what we do here is, I guess the other thing that we would want to do is want to print their ID. And I should stay consistent. Okay, so we have a method which prints the person's name and ID. We have ability to set their ID right here, and an ability to increment their ID. We can do set their ID to, let's say, 42, and set this person's ID to 100. We can set their IDs, and now we can actually increment their IDs as well. So let's say p1 dot name and ID, p2 dot name and ID. So this person, each of them is going to print their name and ID. And then p1 dot they're going to increment. We're going to increment p1's ID, then have them print both IDs again. And what I'm going to do is, let's see, print some prompts messages to make it easier for people to see what's going on. Yes, so I will come to the keyword this right after this print statement. And I'm printing these blank lines just so we can see what's going on. We can separate the different blocks of code that we're working with. Okay. Just gonna copy this. Okay. Here we go. So we're creating Joe. Joe says their name, does their introduction. ArrayLists does their introduction. Now recall we set Joe's ID to 42. We set P2's ID to 100. And then we should have incremented this. What's going on? P1.increment ID. We incremented Joe's ID. Is now 43, while P2's ID stays the same because we did not increment it. Notice that both of these people, or both of these persons, have an ID number. We change for one, but it does not affect the one for the other. And that's what having different instances of the class means. Another thing we can do is, yeah, we can have people communicate with one another. Public void. Just give it, say, a meet, where they meet a person, the other person. And what this is going to do is going to print a message. Hello. Notice here we're working with two person objects. One of them is the reference, so this is where the method is being called, and the other one comes as an argument. And we want to access the names of both of these people, or rather persons. Access their own name using this.name, and then we access the other person's name using the variable name other person, which is here, and the instance variable name name. So if we run this here, we can see at the bottom here, so it says, hello ArrayLists, my name is Joe. And that's because we said p1.meet p2, meaning the reference here is p1. When we say this dot name, we're referring to, or we just say that the variable name, we are referring to P1, who is Joe. When we say the other person, we're referring to this other person here, Ira Floon. Okay. Now, to actually get into the keyword this, this is used in this sense for differentiating between instance variable names. So for example, notice here, in this particular setter method, we have multiple variables called name. We have the argument name right here, but we also have the instance variable name. Now, when we just say name like this, Java refers to the most local variable, meaning the argument here. So when we say this, we can just say name, or it should highlight. Not highlighting. But yeah, so when we just say name, it's referring to the local variable, or rather the argument. When we say this dot name, we are referring to the instance variable. In this particular case, the keyword is necessary in order to differentiate between the two. Because otherwise, Java, if you just say name equals name, that's that's a tautology, meaning it doesn't really do anything because it's referring to the same variable at the same time. And you can see it's highlighting now. So all of these highlighted ones are referring to the argument. But when we say this dot name, we're referring to the instance variable here. That's why it's necessary to use the keyword this. Additionally, we have a case here. Now notice that the variable names are not the same. This is just called ID. The argument is just called ID, while the instance variable is called ID num. So we can actually get rid of it, and this would still work because there is nothing confusing Java to seeing what this instance variable variable is referring to the instance variable. However, I tried putting this in because I like to stay consistent. Whenever I try to reference my instance variables, I use the keyword this so that as a reader of the code, I know that this particular reference is to an instance variable, while anything without the keyword this is a reference to a local variable. That's more of a programming convention. It comes in necessary when you have multiple variables with the same name. So hopefully that clears things up. Now we had a question, was using this parentheses do when using constructors. So we'll get to constructors shortly. I think it's the next topic, methods and constructors. So we'll get to constructors shortly, and then we'll cover what this does in constructors. And thank you, Z-Balls. I appreciate it. Appreciate the support. All right. Now, do we have any other questions about the keyword this or generating classes, meaning when we need to create classes? Another way to think of when we need classes is other than you think of physical objects, classes should represent some kind of data entity that has some instance variables, meaning it has some values to store and it has some actions it can do. But personally, I like the physical object description because I like to think of before actually starting coding, I like to think of what the project is going to be. If I were to plan it out in the physical world, how would I do that? What would the objects be, or what would the physical objects be? And that helps me design what classes are there going to be and what methods are there going to be in those classes. Next up, we have methods. We have already been seeing a few methods. Surprise! As we see here, set name, set ID, increment ID, say name. So these are all different methods. These are all different actions that this particular class can do, and we can call them over and over again instead of having to write this code over and over again. Now imagine if these methods were a bit more complex than a single line of code. they were actually doing some calculations. You may have seen in your assignments. And instead of writing those calculations over and over again, I can just essentially call that particular method whenever I need to. So the way methods work is we specify the scope of the method. In most cases, if the method is going to be accessible by other classes, we want to specify that as public. If a method is only going to be accessible within the class itself, it's going to be a private method. So that's the difference between a public and a private. Same thing with instance variables. We can have them as public, or private, or not encapsulated at all. So we have the scope of the method. Next is the return type of the method. So methods don't always have to print something. They can do other things. So in this case, they don't print anything. It just updates a variable name. It can do some calculation, and the method can return some values. So for example, if I want a method which takes in another number and checks, is that number same as the person's ID number? And if it is, it returns true. If it isn't, it returns false. So this is kind of a check that the method is doing. So in that case, the method would return a Boolean variable, Boolean being a true or false statement. So we would have the keyword Boolean here because that's a return type, followed by the name of the method. So is same, and then we can just say the ID. Now we can calculate if this ID is the same as the ID num. We can say if ID is the same as ID num, true, otherwise return false. And in uppercase A. This is essentially a method. Similar to before, we can call this over and over again, and it'll return us. Unlike the previous methods, this will actually return a value that we can use outside this class. Whoever calls this method could use this Boolean value into something. Let's see, what other things do we have? We have methods, and then we have constructors. Or rather, before we go into constructors, we can do something which is called overloading methods. This may be something you may or may not have seen in the past. And what this does, it's having multiple methods with the same name but different argument types. So that would be and the same return type, I believe. We have a different method with the same name as the one above, but the argument type is a bit different. Instead of an integer, it's a string. And then what this is going to do is we're going to do something simple. Like we're going to try to do something which will have a similar behavior as this one, but actually work with strings instead of integers directly. Now the question is, in what case would you use a private method? And we can use something right here. Is we need some way to convert a string to an integer. And we may need that multiple times instead of just a single location. In that case, we can actually create a private method, which would again return an integer, and call this string to int, or rather, yeah, string to int. Essentially, what this method is going to do, going to convert a given string to an integer. Okay. So what I want this method to do is, again, convert the string to an integer, but it's only needed within our person class. nobody outside this person class should be able to use this method because it's only needed within here, being used as a helper method. So that's why I declare it private. And now, let's call this id2 equals, you can convert the ID for me, and then I can essentially copy, or instead of copying the code, because you want to prevent code duplication, you can say return same ID2. So what this allows us to do is, let's see, need a blank line here, need a blank line here. You can say p1 dot is same. You can give it a numerical value, let's say 43. But we can also give it a string value. And this is allowed in Java because we define two different methods. Although they have the same name, one of them takes an integer, the other one takes in a string. And when we do this, Java knows which particular method we're trying to call based on the argument provided. So we can just test them here. Let's see. We just want to print what's going on here. Now, if we run this, the system does not crash, which is good. And then we see that the person's ID is 43. If I were to change it to a different numerical string, meaning it is a string type, but it's representing a number, now the last value should print false because this person's ID is 43, not 423. Other cases where you might need private methods is if you have a particular method which gets too long and you just want to divide it into smaller methods, then you can create a private method itself. Normally, the length of a method that I like to think of is in two different ways. One of them is that you should be able to describe the purpose of the method in one or two sentences. If it's doing more than one thing, or if it takes more than one or two sentences to describe the purpose of the method or what the method is doing, then you need to have extra methods to actually take care of the details. Another way I like to think of the method length is a method should be able to fit on one screen. If I were to, let's say, even maximize this and turn down the font to something normal, like the 12-point or 10-point font that I normally have, it should be able to fit on one screen. I shouldn't have to scroll up and down to read the whole method. If it is too big, then I need to have smaller. I need to make that method smaller by taking away some of the details and putting them into other private methods. Now, let's say, if like from the outside, another class can only call the public methods, but within the particular class, I can call my private methods to take care of the details for me. This again makes the code a lot more readable, and it simplifies things because if you're having things being repeated, you just need to change them in one place instead of having changed them in multiple places. So that is methods. Constructors. Do we have any questions about methods first? I'm glad I answered your question, Storm. Don't have any other questions about methods, we can move into constructors. Now, constructors are special type of methods, but they are methods nonetheless, almost. So constructors work similarly to methods. thing is that they don't have a return value, but we still don't use the keyword void there. So we just say public in this case, and then a constructor name is the same as the class name. In this case, we call it person. And then we use some arguments. Let's say string name, int ID number, and then int phone number. And then this is where we want to actually what we're supposed to do within the constructor is initialize the values for the instance variables, meaning that we're supposed to get in here a name, an ID number, and a phone number, and we should set the values for these instance variable. So what we want to do is set name, meaning would set the name, set ID, would set the ID number, and set phone num. Let's set the phone number. We haven't created this method yet, so let's do this right now. Let's say we actually have some kind of condition on the phone number. Phone number has to be, what is it? It has to be a value, it has to be a positive value. Let's just keep something simple. If phone num is greater than or equal to 0, then we update the phone number. Otherwise, we leave it as is. Now we can actually initialize the phone number to, let's say, 000, 0, well, other 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And I think that's an allowable string in Java, or allowable integer in Java. So let's say if this is our initialized phone number, and then we only update the phone number if the incoming phone number is greater than or equal to 0. Now, what happens is sometimes we may have more than one constructor. We may have multiple ways to initialize or instantiate an object. So we could have something like public person, and this time we just take in a name and an ID number. This one, we don't require a phone number. So this is a different constructor for the same class. It's just a different way to create a person object. So what we can do here is use the keyword this. I told you I was getting back to this. Sorry, it took me a while. And now we forward the name, ID num, and in our case, the default phone number. And what this is going to do is it's going to call a constructor in the same class that matches this signature. Meaning the first argument is a string, the second argument is an integer, and the third argument is also an integer. And this is the constructor that it matches. So it'll call essentially this particular constructor. So it's called a delegation method, where this particular constructor just calls someone else to do the job for them. In this case, it's this particular constructor. It's going to set the name and the ID and the phone number. And it fills in the missing information that's needed with some default value. And I've seen a lot of assignments for this particular course, especially CPSU 233, where we would be doing something like set name, and then set ID. So yes, this is, or rather ID num. Yes, this is valid. Do in Java, this is valid syntax. It'll get the job done. But you can see that there's code being repeated here, or rather code being duplicated. These two are the same in both constructors. This is why we can use the keyword this, here we go, to let this other constructor do all the job. Now consider if you have to do something different. Let's say instead of the ID number, instead of the name as is, we want to add a prefix to it. Let's just say we want to add prefix P for person. Now I can just do this here. If I had multiple constructors doing the same thing, I would have to make this change in every one of those constructors. But if I use the keyword this and let another constructor handle the job for me, I only need to make this change here. That's it. And this is where the this also comes in handy. It prevents code duplication, and it allows you to make updates in an easier way. And Marmello, I'm glad you understand this now. It does make your life a lot easier. And it, again, prevents code duplication. And especially those students, or rather groups, whose assignments I mark, they keep seeing statements like prevent code duplication in constructors. So this is what I mean by saying prevent code duplication in constructors. Pretty much all the other constructors should be calling the one constructor that does all the job. So let's say if we had a constructor for a public person which just takes in a name. Now it doesn't even take in an ID number. Now what I can do is call a different constructor with the name. Now I can just do provided an ID number here. That's it. And now what this would do is this particular constructor will call this two-value constructor with a string and a name, rather a string and an int, which in turn will call this third constructor with a string, an int, and a second int. And just being able, just calling more methods, if we were to call this particular constructor, this does not cause any extra time, especially with the level of code that we are working with. So this is not going to slow down your project at all. So this is why we can make things easier themselves. If I wanted to do this thing as well, I could do this, but then again, notice we have code duplication almost. So I don't necessarily need to provide this value. I want to be as lazy as possible and let the computer do the job for me. So I'm just going to call this other constructor, which will call the third constructor on my behalf. Now, what we can just do is notice that this is showing us an error now because we don't have a default constructor. Which is something that we need. Or rather, we don't need a default constructor. We just need to specify the values of our specific constructors. Let's say I create these two objects this way, and then I can get rid of these two lines because now I'm using the constructors instead of the setter methods. So also, I don't need this particular line anymore. If I were to run the code, hopefully everything is correct and we see the same results as before. So notice we added the prefix P when we were setting the name using the constructor. And then, so we did it this way. And then we also set this person's ID, which is 42. And then the rest works the same as is. Blueborn, do I teach on YouTube? I don't have a stream on YouTube. I do have my previous channel on YouTube. I think it's the name under I just typed it in. So it was called Zen's Gaming. I do have a few streams, not streams, but like a few videos on there. I think that the playlist was called I think it was called Java Games Programming. I do have some introductory videos on there as well. And if you want, I can post a link to that near the end of today's session. Okay, so hopefully that took care of the basics about constructors and the keyword this. The only thing that we're missing is the copy constructor, which is supposed to take in an object of the same type, an original, and copy all the values to this the new object that we are creating. So this would work as similar to what we've seen earlier. So we get an already existing person that would be called original or ORIG in this case. And then we want to copy this person's name, ID, and phone number into the new person that we are creating. Essentially what we can do is, again, we can use this keyword because this particular constructor does everything for us. We can copy this original's name, ID, and their phone number. I'm just gonna get rid of the P right here to make things a bit more simpler. This is essentially a copy constructor. It gets in object of the same type, and then we just copy the values as is for the instance. We want to copy all the instance variables unless something is specified that we don't need them. In this case, we copy the name, we copy the ID number, and we copy the phone number. Okay. Now, do we have any questions about methods and constructors before we move on? Our next topic is going to be method arguments, passing by value versus passing by reference. Not seeing any questions about methods, constructors, so I guess we can move on to passing by value versus passing by reference. Sorry, blanked out there. Now, question is, Storm, will I continue these tutorials? If there is demand for these tutorials, I will be more than happy to continue them on a weekly basis. Yeah, obviously, if we do more sessions, then we would cover other topics. JavaFX, object inheritance, polymorphism, and so on. If you have specific topics, please send me a message then saying what topics that you would like to see. All right. Now getting back to methods, arguments, passing by value versus passing by reference. Let's try. Once again, yes, you will be able to access this tutorial afterwards. I believe it is being recorded, and I will I will probably post a video on YouTube afterwards. Okay. Do this. Okay. So one thing that we want to do in passing by value is when we work, passing by value is when you have arguments that are primitive type. So for example, we have an int argument here that we call ID. This would be passing by value because when we do in Java, when we pass an argument here, rather, let's say, where was it? The isSame here, we're passing the actual data value 43 to this method here. This is called passing by value. This is for primitive types. But let's say we had something that was not a primitive type. For example, in this meet method, where the argument is an object of type person, we are here passing by a reference because this other person is another object. They have instance variables. They have some values such as a name, an ID number, and a phone number. And so Java does not store this. Java, when you pass in this argument here. So for example, when we have the meet p2, what's happening in the Java virtual machine is that there is a location for a variable called p2, where the value that it stores is a memory reference, a memory location for where a particular actual object is stored. So p2 here, when we said this is happening, the object gets created in the Java virtual machine, and then it's the reference, the address of that object is stored in the variable p2. So the address, what I'm saying here is the reference. So when we say p1.meet p2, we pass the reference this object. And now having this reference, we can do other things like obtain their name. This. That is passing by reference. Now, one thing that could happen with passing by reference is privacy leaks. This is just jumping into the next topic, I believe. Yeah. The next thing that happens when we have passing by reference is privacy leaks, because as soon as I have other person here, what I can do is other person name equals, call it Jack. I can change their name. Yeah, go with that name. I can change the person's name here because this is being passed by reference, not a primitive value. Now, if I do things like say, I want to essentially I want them to print their name and ID again. Then I want to do, this is being printed for the third time. So initially this person's name was Joe, or rather IRF Loon. And then when we hadn't changed it here, but when we call the meet method, ended up changing this person's name. So when we print their name and ID again, we get the name Jack instead. So there is a privacy leak going on in the sense that other object here, the reference for P1, is able to change P2's name. So we want to prevent that from happening. Now the way we can do that is, instead of passing P2 on its own, we can create a copy of P2 and pass that instead. So instead of passing P2 as is, we create a copy of P2 by using the copy constructor that we created earlier. Now this will create a new object in memory, in the Java virtual machine memory, and it's going to pass the reference to that particular object. Now if we run this, P2's name remains the same. Is that concept clear? Does anyone have any questions about what we just did there? Gonna wait a few more seconds, because this is something that you have to get your mind around to see what's going on. When we passed P2 here as is, we were able to change their name, P2's name, Jack, and then when we printed their name, it was printed as Jack down here. But when we create a copy of P2, pass that as a reference to P1.meet, we change the name of whatever the copy is. copy is the copy of P2, but it's not the actual object P2. So we can change their name, we can change their ID, change their phone number, do whatever with it. It's not going to affect P2. And we see the evidence here when we print out their name and ID again. It prints the original name and the original ID. Now, in some cases, you want to be able to. Do you have a question? Are you making a new person in the meet method? Okay, so that's a really good question. Am I making a new person in the meet method? I am not creating a new person in the meet method. I'm creating a new person when I'm calling the meet method. What this is essentially the same as person p3 equals new person. We're creating a copy of p2 here, and we're passing it p3. That was just the previous version I just had was a bit of a shortcut. So now all the what I can even do is pt.name. So we're creating a new object, p3. We don't want the p1 to be able to change anything about p2. That's why we create a copy of p2, and then we don't care what happens to p3 because our original object is p2 and we want it to remain the same. So we create a copy of p2. We call it p3. And then when we say the meet method, we pass p3 instead. So when we run everything, at the bottom here we see Joe's name and then IRF Loon, the original p2, and then p3 with their name changed. Hopefully that clarifies things up. Now, the way to identify privacy leaks is to look at method arguments and method return types. A method argument is a non-primitive type. If it's an object, like in this case, person, then you have a potential for a privacy leak. If a method return value is a non-primitive type, then again, you have a potential for a privacy leak. For example, if instead of saying, let's see, or rather I can create a third class, make it a classroom. This classroom is going to have an array list of person objects that we'll call students. And then again, we'll have a constructor. We'll use the default constructor in this case. We'll initialize the array, public void, and we want to be able to add a student. It would be a person, call it P. So this is a very simple class. What this does is it adds the person to the students array list. In this get student method, it returns the student at index I. Hopefully there's nothing confusing about this because we already went over ArrayLists. This is a very simple class which essentially holds an array list of person objects. Coming back to our driver, what we can do is classroom CR. We can create a new classroom, and then we can add our two original students. And now what I want to do is see. I'm going to print all students. And then the way I'm going to do that is I don't need a loop here because we only have 2 students here. So we know we can make things a bit easier for ourselves. System.out.println cr get student at index 0, get student index 1, and give me also, to make our lives a bit easier, I'm just going to add a toString method for here for my person class, and luckily Eclipse is really nice for that. You can create one for me easily. We want to be able to add the students, print the information. Now what I want to do is I'm going to change P1's name. In this case, let's go with Foo-Bar. I'm going to print P1 again. Or rather, this would be the first student. Would be the second student. Because index 0, index 1, and then this would be index 1 again. Okay, so if we do this, and look at the console down here. So what we're doing is we print the first student, which is Joe, this information. Then we print the second student right here. Now notice we changed the information about P1 here. So when we print the first student again, index 0, it prints the new name for P1. In this case, this is a privacy leak because maybe we, like in this case, it's a privacy leak because we did not want the person or the caller to be able to change the contents of the array, or to change the objects contained in the array list for classroom outside the classroom class. Classroom class. Say that 3 times. And we quickly create a loop that prints all contents of the array. We could, but then we would need a getter for the array itself, since it's created private. Or I can create a method within the class. If we need to, we will shortly. But I just want to talk about privacy leaks right now. So in order for me to prevent the driver to be able to change the CR dot, the get student at 0, we don't want them to change that name. So instead of adding the student as is, we again create a new copy of it and be able to and we add the copy of that student. For example, notice here the name does not change. Similarly, what can happen is you can say, let's see, person P4 equals get student at index 0. Say P4's ID is that. And then try to run this. So again, what's happening is, so we add P1 to our classroom. We print P1's information, which is right here. Oops. We get a P1 themselves, or rather we get the copy of P1 which is stored in the array. So notice that we didn't add P1 as is. We didn't add the persons as is. Instead we added a copy of the person. So we get what was stored in the array, or rather the array list. We change their name, which in turn changes the name of the content or the person stored in the array. This again is another privacy leak. In order to prevent this privacy leak, we can do something similar. Instead of returning the student.getI as is, we make a copy of it and return that object instead. And once again, copy constructor comes in handy because we can just do this. Instead of returning student.getI, we call a copy constructor and make a copy of that particular person object. And we run it. Again, P1's name, or rather Joe's name, remains Joe. It does not change. Okay, we have a couple questions. Can we create a loop that print out all contents of the array? Get a private method. We could possibly do that. Do private. Let's see. Get void that it doesn't return anything. Return students. So Blue Barn, that is a good question, good comment. When you use a for each loop, you're not supposed to be manipulating the array. So I shouldn't be adding or removing things from the student's array when I'm using a for each loop. In fact, Java wouldn't let me do that. It'll throw an exception. So the content of the array should remain the same. This is where it comes in handy, where if you're only using it to, let's say, print something or obtain some values, but not editing anything. It's more of a reader than a writer type. Okay, and so let's say we want to print the students every time we add a new student. So let's try it again. This is where we add the first student. This is where we add the second student. So it prints the whole content of the arrays using the for each loop. Now, does that make privacy leaks? Does that clarify privacy leaks for everyone? Are there still any other questions regarding the topic? So Blue Barn has a question about getters and setters. I guess I skipped over those earlier. Essentially, setters are used to set the values for instance variables. For example, we have set the phone number, set name, set ID. And sometimes they are as straightforward as this, meaning you just assign the value as is. Other times you may have some kind of check on it. These are setters. Getters are again something similar, but instead of updating the value, you just retrieve that value. So in order to obtain this person's name, I would just create a method called getName. To get the ID, I would just create getID. Phone number, get phone num. Now again, they may return the object as is. It may just say return name or return ID num, or they may do something special like change some of the values, or in the example here, for this type of getter method, returns a copy of the object instead of the original object itself. So that's setters and getters. Okay. So we've done arguments, passing by value versus passing by reference. I think we're also done privacy leaks, unless anyone has any questions regarding privacy leaks. Last but not least, we have null references. Now this was something that was specially requested based on some of the coding challenges that happened in the previous week, where we had to deal with null references, and that caused a lot of trouble for a lot of students. So null references are references for objects which haven't been assigned a value. So if I go back to my driver here, let's say I want to create a new person object, P5, or rather a new personal variable, P5, I can give it the value null, meaning this is a reference, a variable name, but it's pointing to nothing. That's what null means, in a sense. So there's nothingness. So this is what this is pointing to. Now, even though P5 is supposed to be of type person, not pointing to anything, I can't call any of the methods. So I cannot really do P5 dot set name. This is because P1 is not really pointing to a person. I mean, it could, because P5 is not really pointing to a person. It could, because that's the type of P5, but rather it's pointing to null. It's pointing to nothing. So nothing does not have a name. That's why I cannot call P5.setName, because when I do, it should give me a null pointer exception, as expected. This is where null comes in. And normally when we want to handle null cases, so for example, instead of adding a student normally, cr.add student, let's say if I want to be able to consider this null case right here. If I keep my code as is, it's probably going to give me a null pointer exception. Because, whoops, what happened there? Because what happens is when we do the add student, we call the constructor, the copy constructor in the person class, which in turn here requests for the person's name, their ID number, and phone number. But notice this is again null. So it doesn't have a name, ID number, and phone number, hence the null pointer exception. And then we can see the trace right here. So it starts off at line 49 in our driver class expected for the classroom, which calls this method, which in turn calls the 3-value constructor, which is right here. And this is where we see the null pointer exception. Now, the simplest thing that we can do is just check that P is not null. As long as P, the reference P, is not referring to a null pointer, we can add it. Otherwise, we can say, let's print out an error message. Try this again. So we add our first person, we add the second person, and the most updated array list. Now when we try to add a third person of null reference, we get this error message, P is pointing to null. And that essentially is how we normally handle null cases. We just want to check if the reference is pointing to null. If it is, we do something else. If it's not pointing to null, we do things normally. And then the question was, can we have primitive type variables be null? And then answered by Blue-Barn, only objects can be null. Primitive types are usually not null. The primitive types are assigned some kind of default value in Java, at least. So for example, we saw ints are always assigned to 0. Strings, I believe, are assigned to empty strings. string is a special type. So let's not worry about strings, but like double is also assigned to 0.0. So primitives are always assigned some default value. Thank you for answering that in chat. And yes, strings can be of type null. Because I can do something like, but I may not be able to do something like this. An error saying it cannot convert null to int. So string is allowed to be null, while val is not allowed to be null because this is of type. So primitives cannot be null. And anytime you have questions like this, feel free to try it out for yourself. Luckily, Java nowadays is fairly secure language, so it's not like you're going to break your computer. It happens. In the olden days, when you were working with other languages like C, there were certain things that you could do which would essentially delete your operating system or make your computer unusable, and you would have to just add everything over, like from the beginning again. Luckily, we don't live in that age anymore. Things are the system itself is protected. You can't really harm your computer unless you do something extra crazy, like. But you would have to go out of your way to do it. I'm not going to recommend anything or even suggest anything like that. Don't do anything crazy, but when you have simple tests like this, feel free to try them out. Blueburn, thank you. I appreciate that. Objects are the same thing as reference types. So objects are actual data in memory for the Java virtual machine. So for example, when we created this thing right here, it created an object in memory. So this takes probably takes a few bytes in memory. It's being stored at some memory location. P1 is a variable. It has a reference to whatever this object is. So if I were to do something like, let's say if I were to get rid of this toString method, if we get rid of the toString method, it prints something different. Rid of my here. So if I were to do something like this, so instead of actually printing the nice representation of person we had, now it's printing the memory address here. So this is what P1 or not P1. Sorry, the copy of P1. Here, let's clarify some things up. Let's go back to driver and say P1 equals 1. So this is our variable P1. And this is the memory location it's pointing to. It doesn't really, have any meaning to us as a person, but this is what Java is using. This is where I believe it's hexadecimal. This is where the actual object is located. Hence, P1 is a reference to whatever object is located in this address. This kind of brings us to the very end. Unless anyone have any other questions, we may be coming to an end. If you have other topics that you would like for me to cover in the future, please either send me an email directly, send me a message either on Twitch or Twitter or on D2L for the course, and then I'll try to cover those in the future. I also have a survey that I have. The information is on my is in the description of the channel. Please do fill out that survey. Please take the time to do so. That in the future I can use that data to show to the department essentially if people found this kind of session helpful, and if you have essentially how to improve this session as well. That would be the request for survey. I will copy the link as well in chat, just in case. Obviously, my computer is being slow. So this is an anonymous survey. I would really appreciate it if you fill it out. And I do see the recommendations for the topics, JavaFX and abstract classes. Also, I was supposed to touch on interfaces. Unfortunately, I skipped over those. But yeah, in a future session, we can certainly do that. Thank you all for coming. And I hope you enjoyed your stay. I certainly enjoyed doing this kind of sessions. I've done them in the past. I always have a good time. And then hopefully we can make this almost either a regular thing, either this year or in the future years for the computer science department at the University of Calgary. Thank you for dropping by. See you next time. You're welcome. Foo-Bar. And please don't call me sir. I don't like being called sir. Right. I think the outro should be taken care of by now.